we are going to discuss about force between two parallel currents. I hope you all know that a current carrying conductor is producing a magnetic field. Am I right? A current carrying conductor is producing a magnetic field. Am I right? Yes. So, this magnetic field will exert a force automatically. Am I right? This magnetic field will exert a force, and the force will be named as magnetic force. Okay. So, can anyone say the equation form for magnetic force on a current carrying conductor? A current carrying wire produces a magnetic field, and this magnetic field will exert a magnetic force. Am I right? Due to this field, there will be a magnetic force. And what is the equation for magnetic force on a current carrying conductor? F equal to I into L cross D. Am I right? Magnetic force on a current carrying conductor. F is equal to I into L cross D. This is the equation for a magnetic force on a current carrying conductor. Okay? And we also know that in our Lorentz force equation, when there is an external magnetic field, it will exert a force on the current carrying conductor. That day we kept a charged particle in the presence of electric field and magnetic field, and that we have discussed about F of E plus F of D. Am I right? Total force is equal to force due to electric field and the force due to magnetic field. So today in particular, what is the Lorentz force equation is saying? The magnetic field, external magnetic field is producing an effect on this current carrying conductors. So what is the equation for Lorentz force equation? F is equal to Q into V cross G. Okay. So from this we can understand that the current carrying wires, they are producing a magnetic field, and they also exerting a magnetic force outside due to the external magnetic field. Okay, I will explain this to you clearly. Okay, so for this force between two parallel currents, we are going to consider two current carrying wires. Please, you can draw these two current carrying currents, straight wires of infinite length. Its length is of infinite. Two current carrying wires of infinite length L and separated by a distance D, and this current carrying wire I am going to name it as I1 and this one as I2. Okay, so this is the direction of I1 and this is I2's direction. Again I am repeating, two current carrying wires of infinite length L separated by a distance D. Okay, the current that is produced in the first wire is I1 and the second one is I2. Okay, yes, we all know according to our right hand thumb rule, if I keep my thumb towards the direction of current, okay, and curl my fingers, it will give you the direction of magnetic field. Am I right? If you keep your thumb on the direction of current and curl your fingers, you can know the direction of magnetic field. Okay, so see here I am doing here, my thumb is towards the direction of current and I am going to curl my fingers. Am I right? So it will go like this and it will come out. Am I right? It is going inside. If I keep like this, first it will go inside and it will come out. Am I right? So for this, if I want to draw the magnetic field in the form of concentric circles, I can draw like this. You can also draw this in your notebook. So the direction will be, here it is going inwards and here it is coming outwards. Are you all clear? First it is going inwards, then coming outwards. Okay? So this is the magnetic field produced by the wire I1. Okay, produced by the wire, let me name it as A and B. Okay, magnetic field produced by A, where current I1 is flowing in the wire. Okay, so what will happen in this case? For I2, opposite. Again the same condition. Am I right? So if I keep my thumb here towards the direction of current and I am holding my fingers, so what will happen? Going inside and coming outside. Am I right? So here also for identification I am drawing it down. Okay. So here also first it is going inwards and this side is coming outwards. Okay. So if you see here the magnetic field, okay, here the magnetic field will produce some effect on this wire. Am I right? So here if you see the magnetic field due to I1 on I2, due to, here it will be into, am I right? Field will go inside because of field is going inside because of the magnetic field produced by I1. So this one, since it is the field produced by I1, I am naming it as V1. This is the field produced by I1, so I am naming this as B1. Okay. So if you look here, what about the field direction here for I1? So here to know the direction for I1, we now know that magnetic field direction for I2. Am I right? Since we are holding inside, so it will be inwards here. And for I1, we have to do for this wire. Am I right? For knowing about the field effect in I1, we have to do here at I2. Okay. So if I am doing here, it is coming outside. Okay. So the effect will be, here you can see the field is coming outside. Because of I2 the field is produced here. So I am naming it as V2. Okay. So here current is going upwards and the field is outwards. So I should point it out here. Upside, outwards. So what is the direction of force? It is moving inside. Am I right? In between the two wires it is moving. Again I am explaining. Current upside. It is moving up. Okay. So field is outwards. So you should curl your fingers outwards. So the direction of the thumb will give you the direction of magnetic force. So the direction of magnetic force is in this direction. Okay. So this is the force exerted on A due to B. Force exerted on A due to B. Am I right? Okay. And for next one, here also I2 is going upwards, but the magnetic field is moving inwards. Am I right? So what should I do? Current is flowing upwards, magnetic field inwards. So the direction of magnetic force, where my thumb is pointing, it is again pointing into the in between the two wires. Am I right? Current upwards, curling inwards, because magnetic field is inwards. I should curl my finger inwards now. So the direction of the thumb shows the direction of the magnetic force. So here also it will be inwards, that is force exerted on B due to A. Understood? From this it is clear that FAB and FBA are equal in magnitude but opposite in direction. Am I right? So can I write the equation like F of AB equal to